Alright, so here we are with Unit 5, Lesson 5, and again, this is really just for the honors classes. So we're going to make a third conversion, and we're going to go between moles and particles. And moles we've already talked about, and we've talked about particles, so it's all based on that number 6.02 times 10 to the 23rd. So don't freak out, it's not that difficult. 1 mole is 6.02 times 10 to the 23rd. Half a mole would be 3.01 times 10 to the 23rd, etc. So, and you don't really have to change that number. That's an exponent. So let's take a look. So that's 1 mole of any substance is equal to that. So if we look at this, let's if you look at this, they give us 3 moles, and they want us to convert it to number of particles. In this case, it is molecules. Well, if you think about it, if 1 mole is equal to that, how would I find 3 moles? Well, I simply just multiply 3 times 6.02 times 10 to the 23rd. So I'm going to get 18.06 times 10 to the 23rd. Now, even though that's not proper scientific notation, right, because this decimal really should be here, that's certainly fine. Don't worry about it. And if you look at this one, they're converting from molecules back to moles. Well, this, if you look at this number, that's double this. That means you have 2 moles. That's very simple. And it really, if you take a much more advanced chemistry course, an AP course or something like that, or a college level course, you would have much more complicated conversions. But in this case, you really do not. Let's go on to this. This is Avogadro's hypothesis. Avogadro's hypothesis is something that you should probably memorize the definition of, because that's really all that you need. And you can see here, this is basically what his hypothesis says. Any 2 samples of gas, or any 3 samples that are at the same temperature, pressure, and volume will have the same number of particles. So what he's saying basically is, if I have the same volume, let's say I have 30 liters of gas X and 30 liters of gas Y, and they're at the same temperature and pressure, they're going to have the same number of particles. So if you take a look at this, it says which of the following would occupy the same volume as 2.5 moles of O2? Well, it would have to be the same number of moles of any other gas. In this case, it would be 2.5 moles of Ne. So both of these would have the same number of molecules because they have the same number of moles and they're at the same temperature and pressure. Okay. You can't really see this one. So it says which of the following would occupy the same volume as 2.5 moles of oxygen? Well, you basically have 2.5 moles times 22.4 liters in a mole. So it is 2.5 times 22.4. It would be, I'm assuming that the bottom one is 56 liters of whatever that one happens to be. Would be the same answer. And that's pretty much it for this conversion. So there's really not much to it.